Hey there, it's me, Brandon, the geology guy. I'm here today to talk to you about the rock cycle. So, you may not know, I teach a Geology 101 class at a community college. Had some questions about the rock cycle and what is the rock cycle? What does it mean that a rock goes through a cycle? Can a rock skip a cycle? What does that really mean? And how can you differentiate between the different types of rocks? Well, it's not really a cycle in the same way that the water cycle or the hydrologic cycle. Really, what the rock cycle is it's explaining the different processes that rocks or materials that rocks are made out of undergo to become different types of rocks. So it's not really so much that a single rock is going to go through the cycle, right? It's the different processes that make rocks and understanding how they interact with each other. So let's start with igneous rocks. Igneous rocks are the rocks that form from lava or magma. Magma being molten rock under the earth, whereas lava is what we call molten rock once it's come up from the earth. So an igneous rock is any rock that was formed from molten rock. So a volcanic eruption, or more often than not, magma deep down in the earth solidifies and turns into rock before it ever has a chance to erupt out to the surface. So igneous, you can think of the word like ignite, IGN, the beginning of both of those words, and that's how you can remember, it has to do with molten rock, something that's very hot, volcanoes, right? And I have here a couple of different types of igneous rock. This one is probably the most obvious to tell that it's an igneous rock, because you can, if you ever look at videos of lava flows, you can see that this here looks pretty similar to the way that lava flows across the landscape. You can see how those bubbles, if you look on the side, there's a bunch of bubbles, and you can see on the top how some of those bubbles popped and were deformed as the lava flowed. So this is a rock we call basalt. It's literally comes from a lava flow. Those were air bubbles or some sort of gas bubbles within the lava. Here we have two different forms of granite. And these are both granite, but they have slightly different minerals in them, which is why you have different colors, but they're both this speckled appearance. These both would have solidified deep under the earth, so they would have solidified from magma, whereas this solidified from lava. Okay, so what happens to rock that just sits out? Maybe it comes out of a volcano, maybe it comes from some other source. Maybe it started as sedimentary or metamorphic rock, which we'll talk about in a second. Regardless of where it originally came from, it's sitting out, it's exposed to the weather. Over time, the wind and the rain, glaciers, snow, ice, they can cause the rock to break and fracture and to fall apart in smaller pieces. As it breaks apart, that's what we call sediment. So sediment could be anything from tiny microscopic grains, what we would call mud or clay, to boulders and everything in between. So I've got some sediment over here. Got a project going on right here, landscaping project, adding some rocks to the beds here. This would basically be sediment. This is some gravel. And here, much smaller particles, right? This is sand. Got some sand here. This is also sediment. Through weathering and erosion, large rocks can become small rocks. That's basically all this is. It's just small rocks. We can take a look at those mineral grains. We can look at them under a microscope, and we can get their physical properties, chemical properties, and we can tell what they originated from. We can tell if they were, prior to becoming sediment, were they another sedimentary rock? Were they a metamorphic rock? Were they an igneous rock? We can look at those and we can tell what they originally came from. And then, depending on what they came from, we might be able to determine again what they were before that. Sedimentary rocks, or sediment just sitting around, doesn't necessarily turn into something, but it can be blown around by the wind, or more importantly, carried around by water. So sediment can end up in the rivers, where it gets transported and be transported thousands of miles away from where it originated. And eventually, where do those rivers go? All rivers eventually flow to the ocean, right? Or will most rivers do. When those sediments end up in the ocean, they settle down. They're no longer moving anywhere, and they settle to the bottom of the ocean. And then more sediment gets stacked on top of them, and more and more and more. And over hundreds of thousands, millions of years, so much sediment can get stacked on them that it compresses them. and it compresses the water out from them, the water molecules out from between the grains, pushes all the air out from them. It will often leave behind minerals that will act as a cement to hold those together. Not only that, but because it's been compacted and buried so deeply, it heats up. So now it's deep enough under the ground to heat up, not enough to melt, but enough to kind of bake it. And as it bakes, and with all that compression and minerals left behind as cement, it can become a sedimentary rock. And so now you have these huge swaths of land, these huge layers that have become sedimentary rock. And here we have a couple of samples. Here, one you can actually see some of the layers that went in there between more coarse-grained sands and more fine-grained sands that were laid on top. Here's one where, again, we have some pretty coarse sand. I mean, that's pretty thick sand. I would not like walking on a beach with sand like that. And then this one is that actually very light. And I know you can't really tell on the video, but it's very light. And you can't even really tell that they're grains. It's very, very, very fine grain. This would have been like a mud, maybe in a tidal flat or something, before it compressed into a sedimentary rock, and there's actually some fossils in there as well. Okay, so with both sedimentary rocks and igneous rocks, there was an intermediate step before becoming the rock, right? So in igneous rock, we start with melting rock, and so we get that intermediate thing that's magma or lava, and then we have so the process of melting, and then we have the state of being lava, and then another process of recrystallization to become the metamorphic rock. In the case of sedimentary rock, we have weathering and erosion as an intermediate process, and then we have the burial and sedimentation becoming sedimentary rock. So there's another type of rock, metamorphic rock, that does not have an intermediate medium, an intermediate thing that it becomes, like sediment or magma. Metamorphic rock is really interesting because, and sometimes hard for us to understand, because what's happening is a chemical reaction. And usually when we talk about chemical reactions, we're talking about what we call aqueous chemical reactions. When you study chemistry at a basic level, you're more often than not studying chemical reactions that happen in a liquid. But what's happening with metamorphic rock is chemical reactions, just like any other chemical reaction, but it's happening in a solid state. So the rock, when being having enormous amounts of pressure and or heat on them, so under those extreme pressures and temperatures, the chemicals that make up the minerals are no longer stable. They don't want to be in their current configuration, and so they begin to exchange atoms with each other. And in exchanging atoms will create completely different minerals than what you started with. The atoms are all the same, but they're configured and arranged in a different way to create completely different minerals. And that's what a metamorphic rock is. And I have a metamorphic rock right here. This one's pretty cool because it's really green, and I don't have a magnet with me, but it has some slight magnetism to it. This is a rock called serpentinite. So this is an example of a metamorphic rock that underwent some extreme pressures, very hot as well, though not as hot as some metamorphic rocks. And so it literally transformed from whatever it was before into this. Now, regarding skipping a step, how does that happen? Well, remember I said that this isn't a cycle like the hydrologic cycle. It's not like a single drop of water going through each step. And hopefully you can see now how any rock that melts and recrystallizes will become a metamorphic rock, or an igneous rock. So if you take metamorphic rock and melt it, and then it recrystallizes, now you have igneous rock. If you take sedimentary rock and melt it, and it recrystallizes, now it's igneous rock. But because of the process of melting and recrystallization, especially when you have different materials that are going to melt and recrystallize at different temperatures, the metamorphic or the igneous rock that you end up with at the end is not necessarily going to have the exact same composition as what it started with. And the minerals are going to be different because they exchange atoms just like the metamorphic rocks do, but while in liquid form. If you have an igneous rock, you can't really tell what it started as. With metamorphic rock, not entirely impossible, because we know that certain metamorphic rocks, when they metamorphose in certain conditions, certain environments become specific. There's kind of like an if this rock goes through this process, it will become this rock. And so we can work backwards. And an example of that would be marble. Marble is a metamorphic rock. And we know that marble forms under high heat but low pressure metamorphic environments from limestone. And so if you have marble, then you can know that it originated as limestone, which is a sedimentary rock. However, there are other metamorphic rocks, like a rock called gneiss, spelled Gneiss. Uh, Gneiss can metamorphose under a whole wide range of parent rocks, can start as different types of rocks and under a whole range of different types of conditions. And so we can't be as certain if all you can tell is looking at the rock. Now you can, if you have a whole collection of rocks that were all collected from the same general area, you can make some hypotheses that way. Sedimentary rocks, it's a much more easy to tell what it originated as because they're still in their original form, just broken down much smaller. And so if you have, I showed you the granite. If you have a bunch of pieces of granite in your sand, then you can say, well, that was a granite beforehand. If you have a bunch of pieces of serpentinite in it, for example, you can tell that it was serpentinite before. You can tell it was metamorphic rock before. And so that's how a rock, or material, I should say, because it's not really a rock. That's how material can go from one form in the rock cycle to another. It's not so much that they're skipping steps, so much as it's an outline of the processes that take place within the earth and what those processes reveal. So I hope that makes sense. And if you want to know more about these different types of rocks and how they form and more details about, say, igneous rocks and how they melt, check out my video on how to melt rock. If you're curious about the other types of rocks that I haven't talked about, leave a question in the comments and I'll be sure to add that to my list of upcoming videos. If you enjoyed this, follow me for more content. I'll hope to be getting more Geology Guy content out soon. Take care and I'll see you in the next one.